Oxidation numbers. So assigning oxidation numbers are important, and the reason we determine oxidation numbers of elements in compounds is that it's a way for chemists to keep track of electron transfer during redox reactions. Let's look at the charges as a refresher. Now remember, the charge of the ion, if it's an ion, all these guys will have a charge of 1 plus. All of these guys in column 2 will have a charge of 2 plus. These guys, 3 plus, 1 minus, 2 minus, 3 minus. So this is important to remember for oxidation numbers and assigning oxidation numbers. We have to know basic rules of how to assign oxidation numbers, and you really have to memorize it. And you might think, oh my gosh, all these rules we got to memorize. But really, you know a lot of these rules already just from assigning charges to ions. So let's look at number 1. The oxidation number of a monatomic ion is equal in magnitude and sign to its ionic charge. Now, we've already done that before. Really, it's nothing new here. These charges are the oxidation number. Bromine ion, bromine charge of 1 negative is negative 1. And that of the F3 plus ion is plus 3. Chlorine is negative 1 as well. Sodium is plus 1. Magnesium charge is 2 plus, so its oxidation number is plus 2. They're all just like the charges that we've already learned. Now there will be some exceptions, and that's what we'll go over right now. Number 2, the oxidation of hydrogen in a compound is plus 1, and the charge is plus 1 of an ion. But here's the exception, except in metal hydrides such as NaH, where in this case it is minus 1. Because we see here that sodium actually has a less electronegativity than hydrogen. Hydrogen would want that electron more, so it's going to have an oxidation number of negative 1. So the same thing with MgA2, for example, as a metal hydride. Hydrogen is going to want that electron more than the magnesium. This way, it will have a charge of minus 1. The oxidation number of oxygen in a compound is minus 2, except in peroxides. Now let's take a look at this for a second here. Oxygen here, we know the charge is a 2 minus. The oxidation number will always be a minus 2, except if it has a bond in a peroxide. So for example, if it's an H2O2, it has to be a minus 1. In a peroxide, it will be a minus 1. And if it's in a compound with a more electronegative fluorine, then it has to be positive, because fluorine is going to pull on that electron much more than oxygen. So the oxygen will be positive. Otherwise, we can give oxygen a minus 2. How about the oxidation number of an atom in an uncombined elemental form is 0. For example, potassium atoms, okay, that would be 0, because there's nothing to lose or gain electrons with. So it's not going to be pulling or throwing away electrons. It's going to be 0. There's oxidation number of 0. Potassium is 0. Sodium is 0. Anything, any metal that's all by itself is 0. Same thing goes with a diatomic like a nitrogen. That's 0. Because nitrogen shares electrons equally. They're two of the same atoms. They're going to share equally, such as the same thing with O2. All of these will have an oxidation number of 0, F2, 0. They're sharing electrons equally. Number 5. For any neutral compounds, the sum of the oxidation numbers of the atom in the compound must equal 0. Right, so if we look at this, the sum has to be 0, such as in sodium chloride. We know the charge of sodium is plus 1, the charge of chlorine is minus 1, and those balance out to be 0. So when we add up the sum of the oxidation numbers of each of the atoms in that compound, we have to get a total sum of 0. Polyatomic ion, the sum of the oxidation numbers must equal the ionic charge of the ion. Let's look at hydroxide here. The total charge of hydroxide ion is minus 1. And if we look at Oxygen is a -2 and a hydrogen is a +1, as we already talked about in rule 2 and 3. Those add up to be -1, so that works out. So the sum of those elements in the polyatomic must equal the ionic charge of the ion. So we're going to use these rules to assign oxidation numbers. Let's look at a neutral compound, water. We know from rule number 2 that the oxidation number of hydrogen in a compound is +1. And there are 2 total +1s there, so the total charge there is +2. Oxygen from rule 3, so the charge here is -2. So together that equals 0. And that makes sense. It's for a neutral compound, you must have an oxidation total sum of 0. Let's look at a charge of a polyatomic ion. So SO4 2-. This has an overall charge of 2-. So all of these are supposed to add up to 2-. Let's look at the oxygen first. Oxygen has a charge from rule 3 of a -2. And we have 4 of those. So the total charge on this is going to be a -8. So sulfur, what is the oxidation number on sulfur? In this case, it has to comply with the -8. And together it has to add up to a 2-. So that means the charge on sulfur, one sulfur, must be a +6. Because +6 -8 is a total charge of -2. Let's try some more. Okay, let's try this one. We'll leave the nickel for last. We'll do the oxygen and hydrogens. So let's just do this. There's 2 of these and 2 of these. We'll just break it up like that so it's easier to see. The oxygen we know from rule 2 is a -2. The hydrogen we know is a +1. So what's the nickel? Well, there's 2 of these, so the total is -4. There's 2 of those, the total is +2. Together, that's a total of -2. It's a neutral atom, so it must have a total charge of 2, or excuse me, it must have a total charge of 0. So if it's going to have a total charge of 0, the nickel must have a charge of +2. So nickel's oxidation is +2, oxygen is -2, and hydrogen is +1. All right, let's do this one. Okay, so oxygen we know has a overall charge of -2. So the total there is -8. 2 times 4 is 8. Potassium we know has a charge of +1. There's only 1 of those, so it's +1. And manganese is one of those tricky transition, but we know what it must be. It must be the total element or total compound must be neutral. So what must be manganese to equal out to 0? That must be a +7. So manganese has an oxidation number of +7. Okay, let's try another one. Na2CO3. Na2CO3. Let's start again with oxygen. Oxygen, we have a charge of -2. The total charge of the 3 oxygens will be -6. The sodium has a charge of +1. The total charge of the 2 sodiums would be +2. We have to have it add up to 0. So what is the carbon going to be? The carbon is actually going to be +4 to make 0. So all those equal 0. Put that up there. So the oxidation number of carbon is +4. And that is in the 4th row, so that, excuse me, the 4th column, so that makes good sense. Let's try some polyatomics. Let's say you have HSO4-. So that's the polyatomic. Let's start with oxygen. Oxygen has a oxidation number of -2. The total charge on both of those, or all 4 of those, is -8. Hydrogen has a charge of +1. There's only one, so it has a charge of +1. Now it must equal, these together must equal a total charge of -1 now. Not 0, but -1, because the polyatomic has a charge of -1. So that means we're going to add +6 here. Sulfur must be +6 in order for it to add up to a total charge of -1. Let's try another polyatomic. Okay, what about HPO4 3-? So together they must add up to be 3-. Oxygen, we start there as a charge of -2. 4 of them have a total charge of -8. Hydrogen has a charge of +1. One of them has a charge of +1. So these two together must add up to a 3- or a -3. So what does that mean? This one must be a +4 because 5 minus 8 equals a -3. So phosphorus has a charge, overall charge of +4. Okay, so I put the oxidation numbers in here already. We want to look at when oxidation number changes in chemical reaction, what does that mean? So we can see here the copper is a 0. It's all by itself, so it has oxidation number of 0. But then we see that it goes to a +2. The silver had a +1, but then it went to a oxidation number of 0. So we see that copper lost 2 electrons and silver gained 1 electron from the whole equation. So thus, if copper lost 2 electrons, loss of electrons is oxidation. Copper was oxidized. Gain of electrons, reduction. Silver was reduced. So increase in the oxidation number of an atom or ion indicates oxidation, such as copper. So we increase the oxidation number. That means it lost electrons. If we decrease the oxidation number of an atom or ion, that indicates reduction. So silver was reduced. Notice that nitrogen is the same, so nothing happened. It was not reduced or oxidized. Oxygen is the same, so that was not reduced or oxidized either.